All right, so we're on trig functions. Yay! How many of y'all remember sine, cosine, tangent from geometry? Y'all remember those words? Sine, cosine, tangent. Oh, you should need one today, though. Okay. How many of y'all remember the Pythagorean theorem? Distance formula. Any of these are ringing a little bell? All right, that's what we're doing. Okay. So we're going to start off with recalling Pythagorean theorem. Okay. Pythagorean theorem can be applied when we have a right triangle situation, right? That's our a squared plus b squared equals c squared. How Pythagorean theorem works is that if I know the measurement of two sides, I can find the other side. Remember doing that? A squared plus b squared equals c squared. Okay. The distance formula. You remember the distance formula? Is how you find the distance from one point to another. So if you have 2 points on a coordinate plane, you subtract their x's and square them, subtract their y's and square them, and find the sum of that, and then take the square root, right? So the distance from one point to the other is found by performing the square root of x2 minus x1 squared plus y2 minus y1 squared. Hopefully seeing both of these jog some memory, dust off some cobwebs. Okay, these are two things that you're supposed to have background knowledge of going into this section. Okay, so we're not going to reteach them. We're just making sure we have them in our arsenal and we're ready to use when we need to use. Cool. All right. Up first, trigonometric functions. So when we are talking about trigonometric functions, we're going to let x and y be ordered pairs of a point a certain distance from the origin, right? The terminal side is going to be your hypotenuse, essentially, of a right triangle, okay? Your x and your y are going to be your distance, right? That's what x and y, the coordinates represent. How far left or right you went, how far up and down you went. That's what x and y represent, okay? This is your angle, okay? We're always looking at it as far as a positive angle, which means that we're rotating in a counterclockwise motion, correct? Now, our trig functions, this is our first thing you're going to write. In geometry, you only learn sine, cosine, and tangent. However, there are 6 functions, okay? Each one of them has their counterpart. So first, we're going to talk about sine. Sine in terms of a coordinate plane is going to be y over our r, and r stands for radius. These are all circular motions, which means that there's a radius. It's the distance from the center, your origin, to the point. So sine theta is y over r. Cosine theta is going to be x over r. And tan theta is going to be y over x. When we put all of this together, we know that x squared plus y squared equals r squared. Does that look similar to our Pythagorean theorem? It does. Instead of ABC, we have x, y, r. Okay. Each one of these trig functions have inverse trig functions, reciprocal functions. So sine theta, its reciprocal is called cosecant theta. And it's going to be r over y. The key word is that they are reciprocals of each other. So instead of y over r, it became r over y. Cosine has a reciprocal function called secant. And secant theta is going to be r over x. And then lastly, tangent has a reciprocal function called cotangent. So we have cotangent theta, which equals x over y. As long as you know your 3 OGs, sine, cosine, and tangent, you can easily find their reciprocal because you're just flipping the ratios, right? Okay. And I know you probably don't need me to say it, but remember, it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. That's why these values say that what they cannot equal. Yes.
R.
Because if you have an R of 0, then you don't have a circle.
True.
You're at the origin, right? You haven't moved. So that's why it goes without saying that R can't be 0, because otherwise you're not rotating. Okay. All right. Questions about our trig functions so far? All right. As long as you know X, Y, and R, can you find the trig ratios? Yeah, you surely can. Okay. So up first, we have the terminal side of an angle in standard position passes through the point 815. Find the values of the 6 trig functions. So what that looks like, it's saying that I have this angle and it goes up here to point 815. And it wants, this is the angle. We don't want to find the angle yet. We just want to find the 6 trig values of the angle, right? So from here, what's given to us? X and Y. We know that X equals 8, and we know that Y equals. And how do I find the R? There we go. So we know that R squared equals our 8 squared plus our 15 squared. I like y'all do Nick calculators. Grab them. Just grab them. They're behind my desk. Forgot about, we did need bigger numbers. So it's going to give us 64 plus 225. Is that 15 squared? Yep, 225. So what does R squared equal? A very big number, huh? We get 289. Okay, we don't want R squared, we want what? R. So R equals what? Well, 289. It's two. Well, how can we break down 289? We're going to take the square root. Is it a perfect square? Answer is 17. So we're going to take the square root of 289. And we end up with 17. So we have a perfect square situation. And now we know that R is 17. So we know that this radius is 17. Now that I have my X, Y, and R, can I write out all 6 trig functions? We surely can. Okay, so we're going to use sine of theta. So sine of theta is what? Y over R, and what's our Y? 15, and our R is 17. Its reciprocal is cosecant theta. So what is this reciprocal? 17 over 15. Cosine theta equals X over R, and what is X? And its reciprocal is secant theta. So what's my secant? 17 over 8. And then we have tan theta. Tan theta equals Y over X. So we have 15 over 8. Its reciprocal is cotangent theta, and we get 8 over 15. How do you feel? Doable? Yeah. Nope, it just asked you for the trig. Easy enough? All right, I told you, it's skills you already have. It's just adding on the trig part. Okay? All right, are you ready to try?
Thing is, I know it gets started last.
Look here. You build on the knowledge, Andrew. We're building. Okay? This is the foundation. All right, are you ready to try? Okay, so here's your point. You have -3 and -4. What's the first thing you need to do? Find your R. Okay, find your R. All right, so we know that x equals -3, y equals -4, and what did y'all find r to equal? 5. Can I write all my trig values now? So we have sine theta equals what? -4/5, and therefore cosecant theta equals. There we go. Does it matter if the negative's in the numerator or denominator? Nope. Cosine theta equals -3/5, therefore secant theta equals. Perfect. And then tan theta, 3/4, and therefore cotangent theta, 4/3. So we feel pretty confident in finding the 6 trig ratios of a point in a circle. Well, a point on a coordinate plane. Yeah? Awesome. Okay, so now it says find 6 trig function values of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0, right? So it gave us, here is our picture. And it says that this is defined by x plus 2y equals 0. And it tells us that our x and our y are 2 and -1, right? So we know that this is 2 and this is -1. So could I find the radius if it's giving me a defined definition for it? Yeah, because we know x and we know y. Okay. We can use any point except 0, 0 on the terminal side to find the trig values. So if I'm going to use x and y, that would fit this. So if I plug in 2, I can find out what y is, right? So we're going to let x equal 2. So when I plug in x equals 2, that's going to give us 2 plus 2 times y equals 0. And what will y have to be to make this true? 1. So y equals -1, which is why we said x and y are 2 and -1. Make sense? So this is just defining this point as a value. Now, once I do that, I can find r, right? It just says that x has to be greater than or equal to 0. What that means is that your x has to be in quadrant 1 or in quadrant 4. Because if x is not in those quadrants, then it would be less than, right? So it can be any value as long as it's in quadrant 1 and quadrant 4. It didn't have to be 2. I could have chose 1. I could have chose 3. I could have chose whatever I wanted to choose for x is fine as long as it satisfied this one rule. Does that make sense? Okay. So now I have 2 and -1. So now I'm going to find my r. So we know r equals the square root, because I know I'm going to take the square root, correct? Of 2 squared plus -1 squared. So r equals the square root of 5. Still with me? All right, so now we have a radical. You're going to leave it in radical form. It wants exact values. So we're not going to put in decimals. We're not going to put in approximations. We're going to write it in radical form. The thing is, we cannot have a radical in the denominator. We have to rationalize our denominator, okay? So starting off with sine. So we have sine theta equals is y over r. What is our y? -1. Our r is the square root of 5. To rationalize the denominator, all you're doing is multiplying the numerator and denominator by that radical. So we're going to multiply the numerator and denominator by the square root of 5. And what we're left with is a radical times itself, sets itself, oh, okay. Oh, that was one. Sets itself free. So we're left with the negative square root of 5 over 5. And that would be our sine theta. Okay? So we can't have a radical in the denominator. We have to multiply by whatever that radical is to the numerator and to the denominator. Did we get it? Okay. Now what's cool here is that your reciprocal is still based off of the initial. So sine theta is that. So cosecant theta equals just negative square root of 5 over 1, which is just negative square root of 5. You're not going to reciprocate the rationalized. You're going to reciprocate still the original y over r. Does that make sense? Okay. I don't think I have enough room to do cosine in that down there. So cosine theta equals x over r, right? What is our x? Oh no, I have a radical. So what am I going to have to do? We're going to multiply the numerator and the denominator by the square root of 5. And we're left with 2 square root of 5 over 5. That is the answer that they want. That's your exact value. What is the reciprocal though? There we go. So secant theta equals the reciprocal of the original, which is just square root of 5 over 2. Tan has no problem, right? Tan is good to go. Tan theta, what's our y over x? And then cotangent theta, what's our x over our y? Which just equals -2. Okay, that's the add-on is when we have a square root, we have to rationalize. And all you're doing is multiplying the numerator and denominator by that square root. Okay. All right. Now we're going to talk about our 6 trig values of our unit circle. Okay. A unit circle means that your radius is 1. Does that make sense? Your radius is 1. And that's just why it's called a unit circle. Okay. So up first is 90 degrees. So when we're looking at a unit circle, we're going to look at our main degrees. So we have 0, 90, 180, 270, and 360. Those are our quadrantal angles. Those are our main degrees that we would be analyzing. Okay. So when you're looking at it, you're only analyzing 0, 0, 0, 1. You're at 1, -1, 0. And you're going to be at 0, -1. Those are your X's and your Y's. Does that make sense? And so now to find its 6 trig ratios, it's fairly easy, right? You're just going to go through and use your rules. X over Y, X over Y, X over Y, right? However, before we do that, we also need to know our what? Our radius. So you got to find the radius at each one of these points. And I don't know why I wrote 0, 0 and no one corrected me. 1, 0. Or here. That's our unit circle. Okay. So if I'm at 0, 1, first thing I'm going to do is find its R. So R squared equals 0 squared plus 1 squared. And what is that? It's just going to be 1. Easy enough. So we know that R equals it's just going around with 1, 0, 0, not 1. And it just keeps going, right? So the R is, no matter what, is going to be what? 1. Easy enough? All right. So let's start off with sine. So the sine of 90 degrees equals what? Sine is what? Y over R. So 1 over 1, which is just 1. Cosine of 90 degrees equals X over R, which is 0 over 1, which equals what? 0. Tan of 90 degrees equals Y over X, which is just 1 over 0. And what does that mean? Undefined. Can I easily find my reciprocals? So for cosecant of 90 degrees, 1 over 1 is still just going to be 1. For secant of 90 degrees, instead of 0 over 1, we now have 1 over 0, which makes it undefined. And then for cotangent of 90 degrees, Instead of 1 over 0, it's now 0 over 1, which makes it 0. Okay? And that is all we're doing for all the quadrantals. Does that make sense? Because you're just using zeros and ones. Okay? The only thing you have to pay attention to is when your 1 is positive and when your 1 is negative, because that changes when you get to the 180 and the 270, right? Those values are going to change. Okay? So hopefully as you keep going and learn it, you'll realize that there are
Good afternoon, Maya.
rules that end up following.
If you are on the CTE or Lowe's hallway and you are currently assigned to the cafeteria,
All right. So, as that keeps going, when you're going around as far as another value other than 1, it's just going to be a multiple of that. Does that make sense? Because your R is now, you're now going to keep following the same rules. You're going to still do the same thing. So if we had to do it here, again, I'm going to find my R. R squared equals -3 squared plus 0 squared. And that's going to give me what? R squared equals 9. And the square root of 9 is 3. So my R is going to be 3. And then I'm going to go through and do the same thing. Pay attention to if there's a 0 in the denominator, then it's going to be undefined. If there's a 0 in the numerator, then it's going to be okay. It's going to be 0, right? So let's do it really quickly. So we have sine of this angle, which in this case is what? Anyone know? 180. Good job. But we're going to just keep it as theta. Sine of theta in this situation is going to be, which is just 0. And it's therefore cosecant theta equals, perfect. Now we have cosine of theta, which is -3 over 3, which equals -1. What is the secant theta going to be? Still -1, perfect. Tan of theta, 0 over -3, which equals perfect. And cotangent of theta, -3. Okay. This is going to be for any angle, no matter what the ordered pair is, that measures 180 degrees. Does that make sense? No matter what the ordered pair is, as long as it's 180 degrees. So on the thing, we talked about, hey, give me a second. Yeah. So these are the ones for no matter what. If the angle measure is 0, 90, 180, 270, or 360, these are going to always be your 6 trig ratios, no matter what the x is, right? Or the y. As long as the angle measure is 0, 90, 180, 270, 360, this is what's going to be true. Cool? All right. And that's it for us. Making sure also, once we start using the calculator, we're going to talk about setting those up correctly.